So we're going to continue our conversation about sine, cosine, and tangent graphs, but we're going to give you a little more detail. So yesterday, you guys just kind of explored what the graphs look like and answered some basic questions about some of their characteristics. So now we're going to not dive into it, but we're going to take little baby steps in because I think that's a better idea. Okay, so if we take a look at sine right now, we notice that we have a graph that kind of oscillates. So sine and cosine graphs look kind of similar. They're called oscillating graphs, but they're also called sinusoidal graphs. One thing we should consider is some of the basic facts that we should know about this. So going back to some of the things we covered in the transformations unit, we should be able to note the domain and the range, as well as like the y-intercept of a sine graph. So if we look at sine, we see that it oscillates forever and ever and ever and ever, having maximums, having minimums, and just probably repeating this pattern. So as a result, we're going to say the domain is negative infinity all the way to positive infinity. Think of any possible x value, plug it in for x, and see what sign of that number would get you. It's a very special kind of function in that sense, like it's always defined. However, when we look at the range, now we're looking at the output of this sine graph. So as I mentioned before, we have minimums, we have maximums. So the minimum for the basic graph is -1, and it goes all the way to a +1. Okay. We also note that sine has a y-intercept located at 0, 0. Right? And there are other things to note about the sine graph, but I figure let's start with some of this. Let's talk about some of these transformations. So this shouldn't be too much of a struggle for you guys because we're going to start off with just some vertical transformations. It's when we get to the horizontal that things get a little more complicated. Okay, so let's start off with just looking at the a value, right? And let's say we're going to start with 0 and go all the way to 10. So 0 and positive values for the multiplier there, right? If I take a look at that, I notice that when a is 1, I get the exact same graph as the parent function sine of x. If I let this play, notice what's happening to the graph of, or notice what's happening to the blue graph as a increases and a decreases, right? Think about a way to verbalize that, to talk about the transformations occurring. We also want to consider something else, and that is, all right, what happens if we have like negative values? So let's change this back to a -10. And now let's make it 0. So notice what's happening between the red graph and the blue graph. Be very careful with the type of transformation you note, because like I said, when we introduce some of the horizontal components, things change. So even though this looks like it might be a reflection over the y-axis, little Beyonce action there, it's not. It looks like it. I see it. I want to believe it, but it's not. This is a reflection over the x-axis. All right? So just be careful. So now let's talk about what happens when we get from -1 to 1 and we go up by 0.1. All right. So notice what's happening when those a values are positive, when they're 0, and when the a values are negative, right? Because it's very important to note and think about what aspects of these characteristics would change. Would the domain change? Would the range change? Would the y-intercept change, right? What does a actually affect in this graph? So